Welcome back to Incremental, the continuous improvement podcast. This is our practice edition where we go through improvements we made through the week and tie them back to lean principles. I am Uriel Eisen.
And I am Devin and Uriel.
And you have a quote.
Are you building a cabin or a cabinet?
Excellent.
Unknown quoter. Well, I mean, I know where I heard it, but
Where'd you hear it?
my friend Mike.
Okay.
I think he also did the one I quoted last week.
Nice.
Full quippy Mike.
Yeah, good to figure out ahead of time and make sure that it is appropriate to build a cabin.
You don't want to build a cabin in the same manner that you build a cabinet because you will never get it done.
But also you don't want to build a cabin if you can learn the thing you need to learn with a cabinet, I think.
I've never even thought about that application. I think the intended use of this quote was like, don't make something absolutely perfect that doesn't have to be.
Yeah, and like scope creep is easy.
Yeah.
I don't know. Yeah, there's a lot of... I was working... I worked with startups for a bunch of years, basically helping them prototype. And there was a startup that had... Like basically startups, we've talked about this, can fall into like three categories of risk: team risk, market risk, and tech risk. Like time machine, probably know, tech risk. Are you the team to build the time machine? And would people buy a time machine? And so they had, I don't know if it was exactly, they had substantial tech risk.
Yeah.
And team risk. But and market risk. But the interesting thing
Triple crown.
The interesting thing to me was that the market risk is really the thing you want to solve first because it's cheapest.
Oh, yeah.
And so they wanted to build a machine that did something pretty complex and difficult. And I told them to put a person in the machine.
Yeah.
We've talked about this on the pod and they didn't do it. Anyway, that would be an example of being able to build a cabinet, but instead they insisted on building a cabin.
Yeah.
And then learning stuff through building a cabin that you could have learned through building a cabinet slows you down massively.
Yeah.
Uses a lot of money unnecessarily.
Yeah. Conversely, you don't want to build a cabinet.
If someone wants a cabinet.
Yeah.
Here it is. No, I don't want to do that.
Is this the cabin for ants? Yeah. Sorry. Have you seen that Portlandia episode where it's like the tiny house episode?
Is it very tiny?
Well, there's like a tiny house, and then in the backyard of the tiny house,
it's a recursive tiny house situation.
Tiny house. It's like the size of a doghouse.
Excellent.
Like someone's like giving the tour.
That's very funny.
Well, I can't quote it to do it justice, but it's hilarious.
That's good.
Anyway, conversely, you don't want to build a cabinet with the tolerances of a cabin either, because you will have a very poor cabinet.
Yeah.
So I think,
I think in all of this, it's bad to build the wrong thing. And so it makes sense.
Sounds so obvious when you say it that way.
Yeah, although no one really takes the time, including me, to make sure. Like A3 is sort of a tool that Toyota came up with to avoid building a cabin when you want a cabinet and avoid building a cabinet when you want a cabin.
Yeah.
And spending more time and money and effort on the appropriate part of the problem or something like that.
Yeah. Where this kind of came home for me this last week. So kind of did one big improvement this last week, but I had many little parts.
Which we teased last episode.
Yeah. So as we've discussed, made the new trunnions with dual vices on them.
Mm-hmm.
So when we used to run automated work with our spindle gripper, that was with one vice on a trunnion, on a short trunnion, and we would put our tray on the table next to it.
I'm imagining to someone listening to this who has no idea what we're talking about.
Yeah.
Yeah.
So those who don't understand, it was a small space. It's now takes up a big space. And the tray where we used to put our blanks or parts to get picked up, there's not space for it anymore there.
Gotcha.
What I realized though is if I made the trunnion so it didn't swing too far, there would still be a smallish amount of room along the whole front of the machine.
Okay.
So I, under duress, because we had parts we had to make, made that tray this last week.
Very cool.
And being a machinist and liking to make beautiful, shiny things, I wanted to make it all CNC'd in the beginning. And then I was like, all of our machines are busy. I think we're just going to manual machine this stuff out of stock.
Okay.
And so it's all very like squared off and not particularly beautiful or special looking in any way whatsoever. But it works.
Excellent.
So it was the cabin version when it comes to like tolerances and finish.
Right.
But it does the trick.
That's awesome.
Yeah.
And then we talked a bit about rewriting the programs for that.
Yeah. This is going to get a bit on the geeky side, but the kind of the macros that both you and I have worked from in the past, and you had your own workaround for this as well. And actually the one we got originally had a dual tray option. I don't even remember how they were doing it. Was it hard coded for position?
I don't remember either.
Yeah, I'd have to go back and look at it. In any case, I was working on a single grid. So basically the program would say, go to this place, pick up a part.
Picture an ice cube tray.
Yeah.
Go to ice cube 1.
Yeah.
Then move over to the next ice cube.
Run your program. Put in the vise, run the program, pick it up, go to ice cube 2.
Yeah.
Pick it up, put it in the vise, run the program.
And then when you get to the end of the ice tray, you're done.
Yeah.
And then the question is, what happens if you want to put 3 ice trays in the machine at different locations?
Yeah. Yeah. So that was the new program I wrote, because the long-term goal for this tray is that it will run a universal program most of the time.
Yeah.
That just runs on center and picks up one piece at each position.
They say put yourself in the perspective of the part.
Yeah. But for this first job we were doing, they're second op parts and they're very small.
Okay.
So we wanted to get more than like 8 on a run.
So you're basically, in general, because of the work you do, you're sacrificing sort of like capacity for ease of setup and like universal, just go to position 1, pick up whatever size block that is, whether that's 1/2 inch by 1/2 inch, all the way up to 3 inch by 3 inch.
Yeah.
And then move over to the next position.
Exactly. And for this, I want to say, go to position 1, then go to position 1A, pick up a part, run it, then go to position 1B, pick up a part, etc. Then when it's finished, A through C or whatever, or
AA through, or is it 1A through,
then go to position 2A, 2B, 2C, etc. And it took a little, like I said, I'm kind of a moron when it comes to coding.
Maybe just an experience.
So yeah, I wrote it all out on Friday while we were like, when we used 3D printed trays, which was cool for the first time. So I wrote it all out on Friday, like bought the trays for printing, and then I came in to test it on Monday. And I was like, yeah, it's just going to work. Right off the bat, it was like, I just kept going back to the same spot.
Nice.
I was like, what is going on here? And then I was able to get it to like go to the next spot in X, but then not go to the next spot in line. I was like, And then I got to go to the next spot in X and the next spot in line. I was like, I've done it. And then it went to the next spot in X at the next tray. So like position 2A, but then it stopped incrementing in Y and was just like running across the X. I was like,
yeah, there's a lot of,
I have sake.
Right. Nice.
It's just weird little logic loops, right?
But you got it.
I did get it. Yeah.
That's cool.
Works great.
Yeah. Interesting. So do you anticipate having 2 templates, one for sort of this workflow that's sort of higher volume?
Yeah, I think so.
And then one for just like, we need to run this and it's better to run 8 of something than 1.
Yeah, I think we'll have probably 3. One that's kind of a universally oriented one that's like 1 part per station. Mm-hmm. One that's a universally oriented that's always 2 parts per station.
Oh, interesting.
For when we get underneath a certain stock size.
Gotcha.
And then probably these ones for
like
finished
a full
part.
custom.
Yeah. When it's second op parts, it gets a little weird with like, how high is the part? Are you grabbing it on center?
Right.
like custom jaws. It starts to get a little funky. So that will probably be full custom. But even this one, like looking at it, this was the very first time I programmed a macro was for these parts the first time around. Mm-hmm. Or maybe it was the second. It's extremely rudimentary, a lot of hard coding. And so I started to parameterize things because the universal program that I have is pretty much fully parameterized.
Yeah.
And much easier to interact with.
Gotcha.
And I think eventually right now, the system runs a main macro, 3 subprograms, and then your part subprogram.
Yeah.
I think eventually I'm going to have it be a one main macro, and may eventually even just for the ease of like tracking because of the volume of different parts that we do, make everything integral into one program. Where I'll like
you run one program and the only thing you're changing is which part programs it's calling.
Maybe even embed that part program in the macro.
So almost to just copy and paste this into the beginning and end or something like that.
Pretty much.
Yeah, I could see upsides and downsides.
Yeah,
for sure.
It's hand editing, but you have to hand edit regardless a little bit.
Yeah.
So it's just kind of like where you're doing it and how many different things are there to track.
Here's a crazy idea.
Yeah.
What if we wrote it into the post processor? Basically calling the macro as a sub program.
Oh, right. Because you can do the like cascading programs thing.
Yeah. So like you would post out of Fusion and it would just call the other program. So you wouldn't even have to hand edit. And then it would have to pass all the parameters. But there aren't that many parameters. It's a little complex.
There starts to be more once, like I realized as I've started to parameterize things, like they do start to add up.
But like 10 or like 100?
Oh, yeah, like 10 or 20.
Not 100. Yeah. So I feel like, anyway.
And potentially you could, with math built into it, you could get it down to a handful, I would think.
Right. Like if you're passing position of a tray and the spacing, you don't really need to tell it its last position. Or things like that. When you say with math, I'm not.
Oh, like, right now, like I think you could derive a lot of the variables from a single variable.
Gotcha.
That when you're hand coding, it's easier to just be like, not bother.
Yeah.
Anyway, that was pretty exciting. And it's fun we haven't really done anything with the gripper in quite a while.
Yeah.
So it's fun to be getting back into it. And I'm very inspired to get the flip station up and running now.
It'll blow your mind. Even though you've watched it and know what it will do.
I know. I'm still a little puzzled. I've been spending time awake at night thinking about how to...
The handoff?
Yeah, well, how to do the like part flip in a way that's pretty universal.
Yeah.
And easily driven by parameters and doesn't require any hard coding.
Yeah.
Because it does start like...
The location of your up to on your hat and then the location of the pocket in the soft draws for your up to vice.
Not so
Is
much
that sort of what you're talking about?
But like depths, mostly depths.
Oh, interesting.
Because it's hard to like grab everything on center. Once you're flipping,
right.
On a hat and things like that.
That's a good point. I mean, I suppose you could probe for that, or
it's really easy to work based on center line.
Oh, here's what you do.
Yeah.
Push it into. Ooh, this would be nice. It's a little tricky.
Yeah.
Does it require no hard coding? I'm not sure. You could go touch it to your tool setter probe and push that. We have like 99 tool pockets, tool registers, whatever they're called in the control. So you could populate a different one for your total length after picking up to, or after picking up, or I don't know exactly how it would get implemented, but I wonder if you could go touch it off. It sort of then is a question of X, Y, where you're touching off on the part to your tool setter, but then you could basically drive it like 0.1 inches below the top of your vice jaws or something like that.
Yeah.
But I would also just wonder if it needs to be universal. I mean, it's obviously better if it's just standardized and you don't need to, like, I tweak it in like X and Y to drive it.
I want
in.
this to be a thing that I can like program it
And hand it.
hand it to an operator,
And they run it.
and they're able to run it. Like they need to have some knowledge of how it all functions and stuff and be able to make a couple tweaks, but it needs to be like,
Yeah, that's
they
fair.
need to not be pulling measurements out of CAD.
To figure out where to go. Yeah, that makes sense.
It needs to be, especially the flip, I think needs to be pretty universal. Like if they need to like tweak the down feed slightly, that's okay.
That's all I basically do, because I drive like in X and Y, I go to the same location and it's just a Z question.
Yeah.
So if that would be acceptable, and that was like the top 3 parameters, it was like Z on your flip station and Z when you go back. It's like your pick Z, your flip Z, and your place Z. Maybe. Anyway, yeah, interesting.
Yeah.
That'll be fun to figure out. I was just reading SMED again, just because it was next to my bed. And I was reading the section on presses and standardizing.
Yeah, heights.
Like, it seems so simple, but most companies don't do this.
Yeah.
Standardize, I think it's called daylight. Like, just standardize the shut height of the press across all dies.
Yeah.
And then just shim your short dies to that height.
Yeah.
And then you never have to adjust the shut height of the press ever again.
Yeah.
And that's basically what we're doing here, right? Standardize where things go and then adapt your setup.
Yes.
Like where the part goes in your soft draws might now be driven by how the flip station functions. As long as it doesn't like make it not function,
Right.
not operate. But interesting. We had an interesting one. Basically, we were noticing, Defects is one of the 8 lean wastes. We were getting dropped parts. No, sorry, not dropped parts. The machine would run, but it would fail. There would be part blanks left on the tray.
Not picking them up.
It was not picking them up. So we sort of watched it carefully. And basically what was happening, I don't know why still, it was coming down and then the gripper was not centered on the pocket.
Yeah.
And so it was pushing it hard up against one side and then lifting.
The issue, anytime I've had an issue with not picking is because it was pushing on one side.
So there is an alignment question because we cut it in location. So it should theoretically be perfect.
Yeah.
It is obviously not. Could be gripper fingers.
Yeah.
It could be that the screws are loose that hold it to the 0-point system. So it is slightly off. Either way, you can drive. It's the easy response from most engineers is to drive higher for higher precision. Always cheaper option is to make it more tolerant of more error, unless it causes other issues.
Yeah.
There's also a conflicting pattern, which is that as you drive precision in a process, your potential precision, your costs often come down. So that's the opposite of what I just said, but both are sort of true in different situations.
The costs come down.
Yeah, like tool and die stuff, if you drive precision much, much higher, like 10x your precision, you often end up with huge cost savings through your line. I mean, those
Operational costs go down.
yeah.
That makes sense.
but that is largely because of designs that are not as tolerant of error. So you're always better off tolerating more error.
Right.
But then you're also better off hitting the targets you need to hit. I think maybe is how that all gets wrapped up. But
Again, perfect balance.
yeah.
Yeah.
So
Goldilocks zone.
we oversized. We just went and I was like, wait a second, our gripper fingers close in the axis that it's too tight in. But when it comes down, there's a big gap between the stock and the gripper fingers. So we can just cut the pocket wider and any uncertainty in position will get centered up as it closes.
Yeah.
So we cut it pretty substantially larger.
How big? Like 50,000?
I think we increased both sides by 50 or 80 thou. Yeah. So there's a good bit of wiggle. And the cool thing is it's now easier to load.
Yeah.
So there's really no downside there. So that was
The
a
only
big
potential downside would be if it could move far enough out that a gripper could come down on top of it.
Yes,
But
for
it
sure.
can't happen.
No, not
Tested
even
it.
close.
Yeah.
Yeah. Yeah. I think those grippers move. Is it like,
80 thou per side.
no, I think it's more than that.
Oh, yeah, it's 4 millimeters per side.
Yeah. So that would be 160 or something, whatever. I don't know what it is.
Yeah.
Over an eighth of an inch.
The
That sounds right.
vices are 4 millimeters total.
Yeah. 2 millimeters per jaw.
Yeah.
Maybe it's more than that. Anyway, whatever it is, it's
a
plenty.
chunk.
It's way more than we need. So, so we were seeing a defect. That's why we started looking at it. And then we just increased its tolerance for error by just increasing the size of the pocket. So that was a big win. We haven't seen a missed part since.
Cool. It is really frustrating when you watch it and you see it grab and then the part just stays and you're like, God, come on.
Yeah. And even more frustrating, which gets back to building in time for improvements, is that we don't watch it. And so you come back and you're kind of like, okay, there's 3 in the tray. We're running it again anyway. Whatever, right? I'll deal with this another time. Meanwhile, you build these cost estimates for your cost of goods.
Yeah.
And a bit one of the big elements is machine cycle time. And meanwhile, you've worked hard to get your cycle times down, but now you're running 3 parts
Twice.
air cutting, just doing nothing. And that has to be amortized over the parts you do get out of the process.
Yeah.
So yeah, it's very impactful.
Just put your blinders on.
Yeah, I mean, we have been for a while, and finally it was just let's just fix this. Also, I wanted to show Sam more about the gripper programs because they're very simple, but daunting when you don't know how simple they are. I feel like it can be a little daunting.
Yeah. Coming back to the inertia of a system.
Yeah. Got a Freddy chip vac.
Nice.
And cleaned out the back of the machine. It was amazing.
Yeah. Is that the first time you've done a full or no?
Yeah.
Yeah.
Yeah. I think I'll do it differently next time. I think I'll just circulate it back into the sump instead of transferring it into trash cans to get the level all the way down and just kind of vacuum around the corners and stuff.
Tried that. Didn't work super well.
We barely have any buildup. Really barely. We have we have a pond filter in the back. Underneath that, we have a tight pre-filter paper, non-woven sort of thing. So there's not much buildup. This has been running probably for 6 months without a clean out. And we had, if you half an inch sort of in the corners, really not much at all.
Yeah. That's really not much.
Anyway, so it was kind of funny because Sam did it with me. And he was like, yeah, this is kind of messy. And I was like, I was like, this is amazing. And he was like, what? Is it? Before you get chips on your hands and coolant, and it was just such a mess.
Yeah.
And this was quite effortless. And now the back of the machine is way cleaner, which aesthetically is really nice.
Yeah.
Because there's just a way to clean up chips, which isn't a paper towel.
Roll of paper towel.
Yeah. And you're for what? It's just going to get covered again.
Yeah.
So that was huge. Kind of more broadly, I think a lot about resistance to doing tasks. And you can be I'm lazy, I'm not disciplined, or you can be okay, what part of this do I not like?
Yeah.
And once you eliminate those, it's often not a big deal. I feel Kanban is a great example of that.
Yeah.
And then adding QR codes to Kanban, also a big example. Anyway.
Yeah, totally.
Right? It's we ran out of paper towels because I don't like reordering them.
Yeah.
And only do it once I see they're really, really low. We were really out of order. And so it's kind of well, I should be more disciplined. Or you can say why is it taking this amount of time? And ideally and realistically, you can just automate a lot of things so they don't happen.
Yeah.
So that was big. Yeah. The Freddy is really nice. Really enjoying having it.
I like ours. Actually, I barely use ours.
That's my goal.
Yeah.
I didn't feel comfortable asking Sam to do a clean out because it's such a gross task.
Yeah.
Now I do.
Yeah.
And so I did it with him with the goal of like,
This is your task.
probably, I mean,
Yeah.
I'm sure I'll do it in at some point, but yeah.
I did it a couple times, just kind of like get a sense of how it worked and like if there was aspects of the process they were very obvious to me, they needed to be improved. But now either one of the employees does one machine clean out each week at the end of the week, and it seems to just be going.
I would love a linkage between the suck blow portion and the open close the vacuum, because if you forget to close the vacuum and you change it to blow,
That happened the other day.
it's quite festive. It's cooling everywhere. Yeah. It's not great. So it would be nice if there was some like either an actual it could be an interlock where you can't do one without the other, or it could just activate both at once. Would anyone want to pay for that from the factory? Probably not. Good chance. And also like, I think it's always easy to add features, but then people don't buy the product because it's just too expensive.
Yeah.
And so like, but I do also think that like retrofit kits would be nice. I also did something a while ago, which maybe we'll just do this. We had an issue where I'd forget to turn the air dryer back on after turning the compressor back on. And so I just put a magnet on the air dryer, and I would never turn off the compressor without that magnet. It was essentially an interlock, but it was more just informational. It wasn't like a mechanical interlock. So like I could imagine making it so you couldn't grab one handle.
Where was the magnet, like over the button or something? How did that work?
So when I turned off the air dryer, I would pull this magnet off. It was a big red tag with a magnet.
Yeah.
I'd turn off the air dryer, walk over to the circuit breaker, turn off the compressor, and put the magnet on the compressor breaker.
Gotcha.
And then when you turn it on in the morning, you pick up that magnet.
You don't just turn the compressor off at its
high on a shelf.
Oh, right. That's right.
Yeah. Doing the service up on that shelf was fun.
I need to get that stuff.
Yeah. So that was one. Ordered a laptop, and that was the problem we noticed, or I noticed. Oh God, right now. Tell me about it. My credit card bill was. I was like, man, what did I buy? Oh yeah, a Freddie and a laptop and some other stuff. So expensive month. The laptop. The goal is this. I was noticing a good amount of waste transitioning between my computer at home and my computer at work. Like like certain tasks were open on one and not the other, and like whatever. Could I single piece flow those tasks and just get them to completion? Yes. Also, a big issue is like CAD has become a bit of a bottleneck in terms of developing new products, in terms of improvements around the shop.
Yeah.
And so I wanted to be able to do CAD at home.
Yeah.
Because often I don't really need to go into the shop on the weekends, for example. Like we don't need to run production, but I end up going because
Just to do CAD.
and then I'm there. So then I do 3D printing, then I do, run the machine, whatever. So
you didn't get CAD.
Exactly. Yeah. So I'm hoping that fixes things. Anyway, so that was a big one.
Nice.
Yeah. I think there were some other things that I forgot to write down, but that was kind of this week.
Cool. Yeah. I mean, I kind of already went through mine. The only other thing was the ongoing post processor. As I mentioned, we crashed the probe, but I think that got fixed, and it's on my task list this week to do a final test and then start integrating it into production.
That'll be exciting.
It will be. Yeah. It's got a bunch of cool features that like, auto little things like it auto block skips probe routines so that
nice.
Restart mid program. It's like preset, because right now I pretty much go through and do that manually on every program that we output.
Oh, really?
Yeah, even just for the basic thing of like often we'll run an op1 and an op2 together in one program.
Right.
When we get to the end of the run, you don't want to, if it's a long part, you don't want to like just cut for half of it. So we jump through, but if there's no block skip on the probe routine, it'll alarm.
Okay.
So that's a little small quality of life improvement, but it will.
That's very cool. Do you know how they implemented that?
I do not.
Interesting.
Yeah. It's got the A-axis limit
Ooh.
set up properly.
Yes.
So again,
And so it's outputting negative values.
yeah,
and positive.
For the geeky Speedio folks, if you have a trunnion or some other rotary thing that is very tall in Z, but down, if it flips over, there's like going from A90 to A270, goes the upside down way, and there's the potential to clip tools that are hanging down. So you can set an A-axis limit in the control to say, like, don't go beyond 180 degrees. However, it doesn't do any like interpretation. So the code, as it's traditionally configured, if you're going to negative A90, that comes out as absolute 270. And so the control alarms, it says you can't go to 270.
Right.
So this code adjustment converts everything to positive and negative 180 numbers.
I would love that one.
Yeah,
I hand edit.
yeah,
It's a bummer.
integrated tool break detection based on whether the tool is set up for tool break in the tool library.
Interesting. And so did that add a tab to your toolpath when you like created toolpath in, well, it's not Fusion.
No, it's in the tool library. So it's
Okay.
It's across the board for that tool.
Gotcha.
So if you don't want it, you have to go delete it out.
There is an option, which I don't know if this is an option in HSM Works
Yeah.
or HSM, whatever. In Fusion, there's an option to add, you know how you sort of work through where you select like what geometry you wanted to machine, what your feeds and speeds are. Like there's all those tabs. There's an option to add a tab and add things like check boxes or something. I wonder if it would be possible to sort of build it into the tool library as a selection thing across the board, but then also be able to go into the tool and deselect it.
Turn it on or off.
Yeah,
That could be cool.
kind of sweet.
Yeah.
Trying to think what else you could do in there. Anything else that you've implemented?
Well, to be fair, I didn't implement anything. I just asked for it. What else do we have? There's all the G54.2 stuff.
Yeah.
And then the G54.2 probing stuff, which was that was the real crux of it.
Right.
G54.2 output is very simple.
Okay.
What else did we? Well, it's simple in the code side. It gets a little, we had to do a 4-digit program number, or 4-digit WCS number. So like when
Because of the rotary.
yeah, because it wants to see a reference offset and then an offset.
Okay.
So instead of being like WCS number 1 through 6 for 54 through 59, you'll do like 1006.
Okay.
And so like the 1 will be 1,000, 2,000, 3,000, 4,000, 5,000, 6,000 will be 54.2 P1 through P6.
Okay.
And then the next 3 digits define your reference WCS. So it can be, if you did 1006, it would use G59 as the reference WCS, G54.2 P1
That's that.
as the working WCS, and you can run through up to the extended coordinates, I think.
Oh, gotcha. I was going to ask why 4, and that is why.
Yeah.
So 1,200 would be like whatever that equivalent is in the extended.
Yeah, they don't go that high, I don't think. But
Okay.
yeah.
Very cool. Well, we are deep in
overtime.
in the machining weeds.
Yeah, that too. Yeah.
Anyway.
I think a few other little details, like I have a toggle for whether the finish position is for the R450 or the S700 machines.
Oh, cool.
Just because that if the code tries to go to the S700 finish position on the R450, it alarms because it doesn't.
That's frustrating. Right.
I think that's most of the stuff. I'm sure there's other things I'm just forgetting right now, but
And again, to keep hitting this point, the very cool thing is the post processor is something that a lot of people just don't touch because it's a lot of programming. It's kind of complex. This is including me. Like I've touched it a bit, but not as deep. You use it multiple times a day. often.
Yeah, and I'll often use it. You know, if we're proofing out a new program, I might repost it. I might just post it once, but usually it's more like 2 or 3 times.
Totally.
And if it's a complex thing, it could be a lot more.
And so taking the time to document all of the workarounds instead of becoming used to them, as like, it's so easy to just become used to our crappy, inefficient working methods, even though they are a critical part of moving forward, is like develop something that works, even if it sucks.
Yeah.
But continue to notice which elements are repetitive or particularly non-ergonomic or time consuming or something. And then kind of chase down a solution, even if it feels like extra work, because it is extra work. And the ROI probably in this case will be 6 months, I would guess.
Yeah, honestly, it wasn't that expensive.
Yeah.
Most of the expense has been my time testing it.
But I think that the difficulty is that each day you probably only waste, which is still a big deal. But one way of thinking about it is you only probably spend like 5 to 10 minutes per day struggling with this pointless thing.
Yeah.
But in order to bite off the project of fixing it, it's been hours of your time. And so it's very easy every day to be like, well, I don't have hours to spend.
Yeah.
I'm just going to do the 5-minute fix.
Yeah.
And that's sort of
100%.
the hard thing.
Yeah. Cool. Is that
Anyway.
a place to wrap us for today?
I think so. Thanks all for listening. You can find me at austere_manufacturing on Instagram.
You can find me at lichen_MFG.
And the podcast is at Incremental CI. And we'll be back next week.
All right.